Hey guys, tonight we imagine a world so familiar that you can feel it under your feet. And then, in one impossible instant, we take away one quiet thing it has been doing for billions of years without ever asking your permission. The floor beneath you seems still. The walls seem still. The trees outside your window seem still. Even the glass of water on the table looks perfectly calm, as if the whole planet has mastered the art of sitting politely. But Earth has never truly been sitting still for you. It has been turning, softly and constantly, carrying oceans, cities, clouds, birds, power lines, sleepy neighborhoods, and your own half-finished thoughts through space at extraordinary speed. Before you get cozy, take a moment to like the video and subscribe, but only if you genuinely enjoy spending time here with me. And if you feel like it, post your location and local time in the comments, because there is something strangely comforting about knowing where in the world you are listening from tonight. Let the world slow down for a moment. Let the fan murmur softly nearby, and let's slip into tonight's journey together. You spend most of your life with no reason to notice Earth spin. That is part of its charm. It never makes a dramatic entrance. It never clears its throat. It simply turns beneath you with the confidence of something ancient and practiced, like a pianist who no longer needs to look at the keys. At the equator, you are moving with Earth at roughly 1,670 kilometers per hour, though it hardly feels that way, which is honestly one of the rudest tricks physics ever played. Even away from the equator, the speed is still enormous. Yet because everything around you is moving together, the motion hides itself. Your chair, your city, the air, the roads, the sea, the mountains, all of it shares the same turning rhythm. And that quiet shared rhythm is what makes the thought experiment so strange. Imagine an ordinary evening, streetlights glow, someone reheats leftovers, a dog turns 3 times before lying down with the seriousness of a tiny philosopher. Somewhere waves fold onto a beach. Somewhere else snow drifts across a road. Somewhere high above, satellites slide through the dark while Earth rolls beneath them. The world feels settled, reliable, a little tired maybe, but dependable. Then Earth suddenly stops spinning. The planet itself halts, instantly, completely. You do not. Neither does your house. Neither do the oceans. Neither does the atmosphere. Everything that was moving eastward with the rotation keeps that motion, because motion is stubborn like that. It likes to continue unless something stops it. This is one of those simple truths in physics that sounds almost too plain to matter until it matters very much. If Earth stopped in a single moment, the surface would stop, but almost everything not locked deeply into bedrock would continue racing eastward at the speed it had a heartbeat earlier. Near the equator, that is faster than the cruising speed of a jet airliner. You can picture how unfriendly that would be. Buildings, forests, vehicles, people, and seas would all be caught in a violent mismatch between what wants to keep moving and what has suddenly decided to become still. The effect would be weaker closer to the poles, because the rotational speed there is lower, but across much of the world it would be immense. So the first great lesson settles in almost immediately. Earth's spin is not some decorative astronomical detail. It is part of the deep background structure of everyday life. You rarely think about it for the same reason you rarely think about the pressure inside your own body. It has been there the whole time, quietly cooperating. For a moment, keep the image gentle and wide rather than harsh. Think of the planet as a ballroom dancer who has been turning for ages, skirts of clouds sweeping outward, oceans held in a subtle curve, day and night changing places with elegant regularity. Then, without warning, the dancer freezes. The fabric does not. The air does not. The music somehow is still playing. That mismatch is where the strange beauty begins, even if the real physics would be deeply chaotic. The atmosphere would keep moving. Since the ground had stopped beneath it, Enormous winds would roar across the surface, especially in places far from the poles. The air would not understand the new arrangement right away. It would continue eastward, carrying dust, moisture, debris, and clouds in a motion that once felt normal and now feels almost mythic. You can think of it as the sky overshooting the planet, like someone taking one extra step after a moving walkway abruptly ends. The oceans would do something similar. Water has mass, momentum, and very little interest in changing plans at the last second. Seas would surge, coastlines would be overwhelmed, entire regions would experience movement on scales that are difficult to hold in the mind. And yet, even here, the science remains oddly elegant. Nothing is happening out of spite. There is no anger in it, just inertia, gravity, pressure, and the patient laws of motion doing exactly what they always do. That is one of the quietly comforting things about astronomy and physics, even when the subject is dramatic. The universe is not moody. It is consistent, sometimes alarmingly so. You might wonder why we do not feel Earth spinning right now if the speed is so great. The answer rests in steadiness. Constant motion in a smooth path can become invisible to the senses. You feel changes in motion far more easily than motion itself. A plane at cruising speed can feel calm enough for someone to complain about the coffee. A ship can glide through dark water with such softness that the horizon seems painted in place. Earth's rotation is like that, only larger and older and more polite about hiding. The stopping, though, would not be polite. And yet, instead of rushing toward every dramatic consequence at once, it helps to stay here for a little while, in that first impossible minute, where ordinary life and planetary mechanics briefly overlap. A lamp still glows on a bedside table. Somewhere, a train schedule has just become extremely optimistic. Somewhere, a loaf of bread is still cooling in a kitchen that has no idea it is attached to a spinning world. The tenderness of daily life remains for a second, even as the deeper machinery underneath it changes completely. That contrast is what makes this idea so compelling. It is cosmic, but it starts at home. The edge of the blanket, the window glass, the hum of a refrigerator. Then suddenly, beneath all that familiarity, you remember that your home sits on a sphere about 12,742 kilometers wide, wrapped in air, carrying oceans, orbiting the sun, turning through space as if this were the most normal thing imaginable, which for Earth it is. There is also a second, quieter layer to keep nearby. Earth's rotation helps shape the planet itself. It slightly bulges at the equator because spinning matter likes to ease outward. The bulge is modest compared with Earth's size, but real enough to matter. Remove the spin, and over time the planet would begin adjusting to a new balance. Water especially would respond. The arrangement of the seas would slowly change, and that slow rearrangement will matter later, so remember it. Keep that image nearby. A planet trying to learn a new shape after forgetting an old dance. For tonight, though, the first feeling is enough. Surprise, scale, the strange intimacy of planetary motion. You are used to thinking of Earth as the stable thing, the unmoving stage where life happens. But that has never quite been true. Earth is not the stage. Earth is part of the performance. It spins, it orbits, it leans, it wobbles a little. It drifts with the solar system through the galaxy, all while giving you the deeply convincing impression that your cup of tea is resting on something solid and still. Which is a marvelous trick, a little dishonest maybe, beautiful definitely. And once you notice that hidden motion, it becomes hard to stop noticing. The sunrise you remember from childhood, the slow travel of shadows across a wall, the stars seeming to wheel overhead, the rhythm of mornings themselves, all of it depends on a turning world. So when you imagine that turning suddenly gone, you are not just removing a physical motion. You are tugging on one of the oldest patterns your life has ever known. In the darkness above, the sky would still be there. The moon would still travel on. The sun would still shine with its ancient indifference, but the air would be moving in ways it never moved before, and the seas would be gathering themselves for a new decision. The planet would have fallen silent in one way, only to become louder in another. And the sky, as we'll see next, would have a great deal to say about it. The air is easy to ignore when it is behaving itself. It slips through open windows, stirs curtains, carries the scent of rain or bread or distant trees, and spends most of its time pretending to be harmless background texture. You notice it when it turns cool against your skin, or when it presses softly before a storm, or when it lifts a leaf just enough to remind you that the world is not as still as it looks. Usually, that is enough. Usually, the atmosphere is a quiet partner in your life, moving with the planet, wrapped around Earth like a transparent ocean, loyal to the same turning motion as the ground below. But when Earth stops spinning, the atmosphere does not stop with it. That detail lingers in the mind because it feels almost unfair. The planet decides to freeze, and the sky refuses to cooperate. The air keeps moving eastward with the momentum it already had, and for a while it would continue at tremendous speed. Near the equator, where the rotational motion had been fastest, the atmosphere would still be racing along at more than 1,000 miles per hour. Even in regions much farther north or south, it would still be moving with startling force. You can think of it as the whole blanket of air trying to continue the old dance after the floor has vanished beneath it. And since air has mass, that motion becomes wind. Not a brisk evening wind, not the sort that nudges tree branches and makes someone reach for a sweater. This would be the atmosphere suddenly sliding over a stopped world, carrying its old velocity into a landscape that no longer shares it. Winds on that scale would be beyond the ordinary language of weather. They would not feel like a change in conditions. They would feel like the sky itself had become a moving surface. It helps to picture the reason in the gentlest possible way. Imagine you are standing in a train station on a very long moving walkway. You, the people beside you, and the air around you are all being carried in one direction together, so everything feels calm. Then the walkway stops in an instant, but your body keeps moving forward because it was already in motion. Earth's rotation is like that, only unimaginably larger. The atmosphere had been moving with the planet, and when the surface halted, the air would continue, at least at first, because inertia is patient and persistent and has very little sympathy for your evening plans. The result would not be even everywhere. That is another quiet detail worth keeping close. Earth's rotational speed is greatest at the equator and drops steadily toward the poles. At the poles themselves, the spinning motion is effectively zero in the sense that you are turning in place rather than being carried in a great circle. So the fiercest atmospheric motion would be around equatorial and mid-latitude regions, where the ground had been moving fastest before the stop. Closer to the poles, the mismatch between air and land would be far smaller. That means the sky would become a map of unequal violence. Some places would endure far greater winds than others, simply because of where they sit on the globe. Geography, which already shapes so much of weather, would suddenly matter in an entirely new way. Latitude would become destiny with a kind of rude efficiency. And the air would not just move. It would slam into mountains, funnel through valleys, tear across plains, and shove against city blocks and coastlines with astonishing pressure. Wind is easy to underestimate because it is invisible. You see its effects, not its body. You watch trees bend, doors rattle, clouds march overhead, but the air itself remains unseen, as if that makes it polite. Yet at high speed, moving air can carry immense energy. It presses, it erodes, it lifts, it breaks. It turns dust into a veil, and water into spray, and familiar landscapes into something raw and rearranged. Still, even here, the science can be held softly. The atmosphere would be doing what fluids do. Air behaves like a fluid, flowing, compressing, swirling, responding to pressure differences and boundaries. The moment Earth stops spinning, the old balance is gone. The atmosphere would need time to redistribute, time to lose its inherited motion through friction with the surface and through vast internal turbulence. That means the wildest phase would not last forever. The winds would gradually weaken as energy was transferred, scattered, and transformed. But during that adjustment, the entire weather system of the planet would be in shock. Clouds would be caught up in it too. The sky, with its familiar west-to-east patterns in many regions, is already shaped by rotation through the Coriolis effect, that subtle influence that bends moving air across a spinning planet. It helps guide trade winds, jet streams, storm rotation, and the long, graceful paths of pressure systems. Remove Earth's spin, and you remove that organizing influence. But in the first moments after a sudden stop, the problem is even stranger. The old winds remain. The old streams of motion remain. The atmosphere is still carrying habits learned from a rotating world, except the world has changed the rules without warning. So the sky would become confused before it became different. That is a comforting thought in a strange way. Even the atmosphere needs a little time to understand a new reality. It does not switch instantly from one neat arrangement to another. It stumbles, it overshoots. It tries to keep doing what it had been doing, which, honestly, is relatable. You can imagine layers of air moving at different speeds, colliding, mixing, and rolling into tremendous turbulence. The lower atmosphere, dragged by contact with the roughness of land and sea, would begin to slow faster than the air above. That difference in speed with height is called wind shear, and on a normal day it already matters for storms, aircraft, and cloud structure. On a suddenly stopped Earth, shear would become enormous. The sky would be stacked with conflicting motions. Air near the ground would scrape and break. Air above would continue rushing onward. Between them, invisible rivers would twist into instability. And then there is sound. A world under those winds would sound different. The ordinary soundtrack of life would be swallowed by a vast continuous rushing, a deep mechanical roar made from nothing mechanical at all, just air and speed. Windows would shudder, surfaces would vibrate, and every exposed edge would begin to sing in its own pitch. It is an eerie thing to imagine. The atmosphere, usually so silent in its power, suddenly loud enough to dominate the senses. As if the planet had been carrying a giant hidden instrument all along, and someone had struck a single, impossible chord. There is another detail that stays with you once you notice it. Earth's atmosphere is not some thin decorative lining. It weighs a great deal. At sea level, the air above every square meter presses down with a force of roughly 10 tons, though it balances so perfectly with the pressure inside your body that you almost never think about it. This blanket of gas is deep, heavy, and dynamic. It stores heat, water vapor, momentum, and motion. So when it is set loose from the spinning ground that helped organize it, the consequences are not small. They are global. Yet the atmosphere would not simply rage forever. Friction is always waiting. The roughness of mountains, forests, oceans, fields, and buildings would steadily rob the moving air of speed. Energy would be transferred into heat, turbulence, and pressure changes. The sky would exhaust itself, slowly and expensively. Over time, a new atmospheric pattern would begin to emerge, one shaped no longer by a daily rotating Earth but by a stationary world facing the sun on one side for months and the dark on the other. That new climate will matter later, so keep that image nearby. A bright side, a dark side. Between them, a restless boundary. For now, though, the first chapter of The Air is all about momentum. The atmosphere remembers the old Earth for a little while. It carries forward the memory of spin, and memory in physics can be astonishingly forceful. It is almost poetic that the invisible thing would become one of the loudest consequences. The ground stops, but the sky refuses to forget. The air keeps the old rhythm just long enough to reveal how much the world depended on that hidden turning. Every breeze you have ever felt was already part of a rotating system. Every cloud you have watched drift past the moon was already obeying a spinning planet. Even the calmest evening had motion folded into it. You begin to understand that stillness on Earth was never simple stillness. It was coordinated motion, shared motion, a beautifully organized agreement between land, sea, and sky. And while the sky is still racing eastward, the oceans are preparing their own response, slower to gather perhaps, but heavier, deeper, and in some ways even stranger. Water is slower than air to reveal its intentions, which gives it a kind of dignity. Wind announces itself quickly. It rushes, whistles, rattles, and makes sure everyone notices. The ocean is heavier, quieter at first, almost thoughtful. It can look still while carrying enormous force. It can seem patient while rearranging coastlines. So after the atmosphere begins its long, wild slide across the stopped planet, the seas would follow in their own way. And what they would do next is one of the strangest parts of the whole story. Right now, the oceans are not spread across Earth evenly by accident. Their shape is guided by continents, gravity, the seafloor, the moon, the sun, and also by Earth's rotation. That spinning adds a gentle outward effect strongest at the equator, which helps make our planet slightly wider around the middle. Because of that, ocean water is not settled on a perfectly round Earth. It is resting on a slightly bulging one. The sea level near the equator sits farther from Earth's center than it would on a non-spinning planet. The difference is not tiny in human terms. Over very long distances, it amounts to many kilometers of shape built quietly into the world. So when the spin disappears, the oceans inherit two very different problems at once. The first is immediate momentum. Like the atmosphere, the water has been moving eastward with the rotating Earth. If the ground stops abruptly, the oceans do not politely place their teacups down and stop too. They keep moving. Vast masses of water would surge eastward relative to the surface, carrying the old rotational speed into a world that no longer matches it. Along coastlines, this would create movements far beyond ordinary storms or tides. The sea would rise, rush inland, withdraw in places, pile up in others, and behave less like the familiar edge of a continent and more like a planetary-scale slosh. The second problem is slower and quieter, but in the long run perhaps even more profound. Without rotation, the equatorial bulge would no longer be supported. Earth would begin, over time, to settle toward a rounder shape, or at least a shape closer to what gravity alone prefers. Water, being wonderfully obedient to gravity, would start migrating away from the equator and toward the poles. Entire ocean basins would slowly be redefined. Land now dry would vanish under new seas in some regions, while parts of the equatorial zone could become newly exposed. Keep that image nearby because it feels almost mythical at first. The seas creeping toward the poles, the middle of the planet drying out, new continents emerging in a vast band around the equator, old coastlines becoming memories. But before that long transformation, there is the immediate motion, and it helps to stay with that for a while. Imagine the ocean not as a flat blue surface, but as a moving body with depth, layers, momentum, and weight beyond intuition. A single cubic meter of seawater weighs about a metric ton. Now scale that to a coastline, then to an ocean basin, then to the whole connected world ocean. When such mass is already in motion and the surface beneath it abruptly stops, the result would be enormous surges sweeping across the planet. Calling them waves almost feels too small. This would be water carrying the memory of a rotating Earth into a still one. The geography of the continents would shape how this movement unfolds. Narrow seas might funnel water into terrible heights. Broad coastlines could be overrun by long, fast walls of moving sea. Islands would be especially vulnerable, caught in the path of water with little interior distance to hide behind. Inland areas connected by bays or estuaries could suddenly become extensions of the ocean. Some regions might see the sea race in and then tear back out again as basins try to settle into new balances. And all the while, the sky and ocean would be interacting. The atmosphere's violent eastward winds would drive the surface waters further, adding force to force. Air and sea would no longer move together in the easy partnership you are used to. They would be dragging and shearing against each other, creating spray, foam, pressure differences, and layers of chaos from the upper ocean to the lower clouds. It would be a world where the line between sea and sky grows blurred, both of them still carrying the old spin, while the land below has already changed its mind. There is something almost tragic in that delay. The land stops instantly. The air and water remember longer. And memory in water can be especially beautiful to think about. Even in the ordinary world, the ocean stores traces of old winds, vanished storms, distant seasons. Swells can cross thousands of kilometers after the weather that created them is gone. Deep currents move slowly enough that parts of the ocean are still responding to climate events from the past. Water is very good at carrying history. In this strange thought experiment, it would carry the history of Earth's rotation itself. Over longer timescales, the redistribution of the oceans becomes one of the most fascinating consequences of all. Because Earth is currently slightly flattened at the poles and bulged at the equator, sea level is arranged around that geometry. Remove the spin, and the equipotential surface the oceans seek, essentially the shape water wants to take under gravity, would change. Models of this scenario suggest that water would migrate poleward, forming immense polar oceans, while leaving a broad equatorial land belt exposed. That belt would not be a neat ring of clean beaches, sadly. Reality is rarely that stylish. It would be a transformed planet of old seafloor, altered basins, strange inland depressions, and reshaped continents. Some current ocean floors near the equator could become dry land. Some areas near the poles would drown beneath kilometers of new ocean. The map of the world would need to be redrawn with a kind of exhausted disbelief. You might think of the current equatorial oceans, especially the Pacific, as permanent features, but they are permanent only inside the lifespan of a human mind. Planetary surfaces are much less loyal than they seem. Given a large enough change in energy or geometry, water moves. It always moves. It seeks the shape allowed by gravity and the boundaries that contain it. Take away the spin that helped sculpt the old arrangement, and the sea begins composing a new one. This would not happen in a week or a year. The instant stopping is catastrophic in the short term, but the full reorganization of the oceans would unfold over much longer periods, through immense floods, retreating shorelines, sediment shifts, crustal adjustment, and the slow insistence of gravity. The world would pass through phases. First, the violent inheritance of momentum, then the deep planetary rearrangement. It is worth pausing on why the equator currently holds more water. The spinning Earth creates centrifugal effect, more precisely an outward inertial effect in the rotating frame, strongest at the equator. It is subtle compared with gravity, but over an entire planet subtle forces can leave large signatures. The equatorial radius of Earth is about 21 kilometers greater than the polar radius. That is not because Earth is soft like dough, but because over geologic time, rock and ocean alike have responded to rotation. The planet you know is already shaped by motion. Remove the motion, and you are removing a sculptor that has been working since the early solar system. Which is a wonderful reminder that even the shape of the world is partly a record of movement. If you were somehow floating high above this stopped Earth long after the first chaos, the oceans might look unfamiliar in a deeply unsettling way. The bright reflective spread of water could gather around the poles like two giant caps, while the equatorial region, once associated with warm seas and island chains, might become a vast exposed belt. It would be Earth, unmistakably Earth, but with the furniture moved around by a cosmic hand. And still, none of this happens randomly. Water is following energy, gravity, and geometry. It is obeying the same quiet laws that guide rivers downhill and tides along shorelines. The scale is what makes it feel surreal. A river changing course is geography. An ocean abandoning the equator feels like myth. But physically, the logic is the same. Water seeks balance, then keeps seeking it when the balance changes. There is another tender little detail hidden inside all this. Coastlines, which feel so fixed in memory, are actually temporary sentences written between land and sea. They shift over centuries, millennia, and ice ages. Human beings simply live too briefly to see most of that motion directly, so we treat shorelines as permanent. This thought experiment tears away that illusion. It reminds you that the edge of the sea is only ever a negotiation. And if the oceans are negotiating again on a motionless Earth, then the planet itself must also renegotiate its shape. The seas cannot move toward a new equilibrium without the solid Earth responding too. The crust, the mantle, the bulge around the middle of the world, all of it becomes part of the next quiet question. Because a stopped Earth would not only have new oceans, it would slowly become a different kind of planet. The planet beneath the oceans has been listening to all of this in silence. That feels appropriate somehow. Rock is slower than water, slower than air, slower than almost anything that makes noise in your daily life. A mountain can look eternal while continents drift beneath it. A plain can seem perfectly settled while the crust below is under stress, lifting, sinking, bending by tiny amounts over ages so long they hardly fit inside ordinary language. So after the sky has rushed and the seas have surged, your attention settles on the Earth itself, the old solid Earth, and you begin to notice that even it was never as fixed as it seemed. Right now, the world is not a perfect sphere. It is slightly squashed at the poles and widened at the equator, a shape called an oblate spheroid if you want the formal phrase, though it sounds much more elegant than it looks in textbooks. In plain terms, Earth is a little thicker around the middle. That is the mark left by rotation. Over immense stretches of time, the steady spinning of the planet has encouraged rock and water alike to sit a bit farther out around the equator than they would on a perfectly still world. You do not notice this while walking down a street or making coffee or trying to remember why you opened a particular tab on your laptop 3 minutes ago. The planet feels round enough. Still, the difference is real. Earth's equatorial radius is larger than its polar radius by about 21 kilometers. Across the scale of an entire planet, that is not a wild distortion, but it is far from nothing. It is a signature, a quiet note written into the shape of the globe by motion. So when the spin stops, the shape becomes a problem. The Earth would no longer be in the right form for its new condition. The old bulge around the equator would be a relic of a motion that no longer exists. Gravity, which had always been there patiently managing the deeper architecture of the world, would begin to pull things toward a new equilibrium. Water would respond first and most obviously, because water is so willing to move. But the solid planet would respond too, just with much more geological dignity. You can picture it as the world slowly relaxing after holding a posture for far too long. A stopped Earth would begin trying to become rounder. The equatorial regions, once held slightly farther out, would no longer have the same reason to remain so extended. Material in the crust and mantle would shift over long timescales. The surface would not snap neatly into a new ball, of course. Earth is layered, partly rigid, partly ductile, and full of structures inherited from billions of years of formation and tectonic history. But the broad tendency would remain. The old shape would start to soften towards something new. And that matters because changing shape means changing height, pressure, drainage, stress, and the distribution of mass. Imagine ancient seafloor in equatorial regions becoming exposed as water migrates poleward. Imagine those regions not just drying but also sitting on a planet that is subtly adjusting beneath them. Some land might rise relative to the new sea level. Some basins might slump. Some areas would crack, fold, or settle as the crust responds to changing loads. Even the removal of ocean water itself changes how the crust behaves. On present-day Earth, we already know that land can rebound when heavy ice sheets melt or when the weight above it changes over time. The crust is not infinitely rigid. It flexes. Slowly, yes, but truly. That means a stopped Earth would be engaged in a double rearrangement. Water would be moving. Rock would be answering. The emotional effect of that idea is oddly beautiful. The world would not merely suffer a dramatic event and then freeze into a new stillness. It would continue changing, quietly, patiently. The first day would be violent. The next centuries would be strange. The next millennia would be full of adjustments almost too slow to watch but impossible to stop. The planet would be teaching itself a new balance. And balance, in planetary terms, is never simple. You can think about Earth as layers nested inside one another. A thin crust, a thick mantle beneath it, hot and able to flow over long periods, a liquid outer core, a solid inner core. Rotation affects the whole planet in different ways, directly and indirectly. The exact details of how the interior would respond to a sudden halt are complicated, and some parts remain difficult to model cleanly, because a truly instant stop is not something planets usually practice. The universe prefers transitions with fewer tantrums. But broadly speaking, the removal of rotation would alter the distribution of forces that helped shape the planet's figure, and the solid Earth would take a very long time to settle into its new form. There is also the question of gravity as you would feel it. On the spinning Earth, the outward inertial effect from rotation slightly reduces your effective weight, especially near the equator. It is a small reduction but measurable. If the planet stopped spinning, that little outward effect would vanish. You would weigh slightly more than before, most noticeably at low latitudes. Not dramatically more. No one would suddenly feel glued to the floor like a dramatic scene in a science fiction film. Physics is often less theatrical than cinema would prefer. But the difference would be real. At the equator, effective gravity would increase by a small fraction, enough to matter scientifically, though probably not enough to become the first thing on your mind in a world already dealing with much larger problems. Still, it is one more reminder that rotation is already folded into the normal version of being alive here. Even your weight has been quietly edited by Earth's spin. The poles would become stranger too. On today's Earth, gravity is slightly stronger there than at the equator, partly because of the shape of the planet and partly because there is no rotational reduction in effective weight at the pole. On a stopped Earth that became rounder and redistributed its water toward the poles, those regions would become even more central to the new arrangement of the planet. Vast polar oceans could gather there. The old image of the poles as icy endpoints would fade. They might become the dominant basins of a restructured world. And somewhere between those great water masses, the equatorial belt could emerge as an enormous land region unlike anything in modern geography. Parts of it might be flat, broad and mineral-rich, exposing former ocean floor. Other parts could be broken, uplifted, scarred by the stresses of unloading water and reshaping crust. New interior seas might form where basins remain. Salt flats might stretch where shallow equatorial waters once shimmered under trade winds that no longer exist. The map would not merely change, it would become hard to recognize. There is a quiet philosophical pleasure in this if you keep the scale wide enough. You spend your life learning the world as a fixed set of names. Ocean here, desert there, mountain chain along this edge, tropical belt around that part. But all of those names sit on top of dynamic systems. Earth is not a finished object. It is a process that happens to look solid from inside one human lifetime. A stopped Earth makes that truth impossible to ignore. Even the familiar idea of up and down would feel a little different once you understand what the planet is doing. Sea level is not just a simple height measured from some cosmic ruler. It is tied to gravity, shape, and the equipotential surface that water follows. Change the shape and rotation of the planet, and sea level itself becomes part of a new geometry. What counts as lowland and highland changes with it. Coastlines redraw. Drainage patterns reorganize. Rivers seek new paths. Lakes appear where no map expected them. Old ports become inland ruins. Entire cultural memories attached to shore and horizon would become ghost stories from a faster world. And under all of this, tectonics would continue in some form. The deep engine of plate movement is driven mostly by internal heat, mantle convection, slab pull, ridge processes, and the long machinery of planetary cooling. Rotation is not the main motor of plate tectonics. So the stopped Earth would still, over great spans of time, remain a geologically living planet. Volcanoes, quakes, mountain building, crust recycling, all of that could continue, now working on a rebalanced globe with new oceans, new loads, and a different surface logic. That is somehow comforting. Even after such a profound change, Earth would still be Earth in its deeper habits. It would still convect, crack, build, erode, and reshape. The old motion of daily spin would be gone, but the deeper motions inside the planet would keep their slow, ancient conversations. Which means the world would not become dead, it would become different. And as the planet slowly relearns its own shape, another change would begin to press itself into every surface and shadow. The most familiar rhythm of all, the one that once divided morning from evening, would no longer arrive every 24 hours. The stopped world would still turn around the sun in a larger sense through its yearly orbit, but its daily spin would be gone. And that would change light itself. Light has always been one of the gentlest ways Earth explains itself to you. Morning arrives across the wall in a pale stripe. Afternoon leans warmer and lower. Evening softens edges, pulls long shadows across the floor, and quietly reminds the day that it has done enough. You have lived inside that rhythm so completely that it can feel less like astronomy and more like atmosphere, less like physics and more like mood. A day seems natural. A sunrise seems inevitable. Night feels like part of the contract. But Earth's daily cycle of light and darkness exists because the planet spins. Take away that spin, and the sun does not stop existing, of course. Earth still travels around it once a year. The planet is still in orbit, still bound to the same star, still crossing the same great ellipse through space. What disappears is the daily turning that brings your part of the world into sunlight and then carries it back into darkness. Without that rotation, one full cycle of daylight and night would no longer last about 24 hours. It would stretch out across an entire year. That idea lands slowly in the mind because it feels so wrong at first. 1 year for a day, 1 year for a night, or more precisely in many places, months of unbroken daylight followed by months of unbroken darkness, depending on the exact geometry and the tilt of the axis. The familiar movement of the sun across the sky would become something almost ceremonial. It would rise very, very slowly, climb with impossible patience, hang for ages, and then descend with the same vast reluctance. Time itself would seem to change character. On the Earth, the sun appears to move because you are rotating into and out of its light. The star is not hurrying around you each day. You are turning beneath it. A stopped Earth ends that illusion. The only remaining large motion that changes your angle to the sun is the yearly orbit around it. So the sky would begin to operate on orbital time instead of daily time. Dawn would not be a brief event. It could last for weeks. Sunset too. Noon would become a season. Keep that image nearby because it matters more than it first seems. The pace of light shapes temperature, weather, biology, sleep, migration, culture, agriculture, architecture, and memory. Human beings do not merely live under the sun. They live by rhythm. We notice patterns before we understand them. We wake to brightness, slow in darkness, build habits around repetition. A world with a year-long day would feel less like an unfamiliar schedule and more like an entirely different kind of existence. If you stood on such a world after it had settled past the first chaos, the sky in some regions would become astonishingly strange. Near the subsolar region, the place where the sun stands highest, long months of heating would build and build. The ground would absorb sunlight day after day with no true nighttime break. Stone, soil, roads, rooftops, and oceans would keep taking in energy. Temperatures would rise far beyond what most present-day climates experience, especially in dry continental interiors. The land would bake under a star that simply refused to leave. Meanwhile, on the opposite side of the planet, darkness would settle in with equal stubbornness. Months would pass without sunrise. Heat would radiate away into space. Surface temperatures would plunge. The air would cool, contract, and change density. Ice would spread across regions that never see it now. Oceans on the dark side would lose heat continuously, their surfaces freezing in many places, their deeper waters preserving warmth longer but not forever. Entire landscapes would fall into a silence colder than ordinary winter, because winter at least still carries dawn in its pocket. And between those extremes, there would be transitional zones, long belts of slow sunrise or slow sunset, places where the sun lingers near the horizon for immense stretches of time. Those regions might become the gentlest parts of the new world, at least in theory. Perpetual dawn, perpetual dusk, soft angled light, temperatures less severe than the blazing day side or the frozen night side. A planet of extremes usually hides its most livable places near the boundaries, which feels a bit poetic, if mildly inconvenient for real estate. This is where the tilt of Earth's axis adds a layer of complexity. Earth is tilted by about 23.5 degrees relative to its orbit around the sun. That tilt is what gives you seasons right now. On a stopped Earth, the tilt would still matter, and it would shape how the long yearly cycle of daylight reaches each latitude. Some regions would experience the sun climbing high for part of the year and sinking low or disappearing for another. Near the equatorial belt, the pattern would differ from what happens near the poles. The exact details would be wonderfully complicated, because the sky would still be governed by orbital geometry, just without the quick daily spin that usually smooths everything into a familiar pattern. The emotional effect of this is surprisingly large. Remove the day-night cycle, and you do not just change the sky. You change the feeling of time inside a human life. Ordinary things become difficult to place. What is morning when the dawn lasts 3 weeks? What is bedtime when the sun has been hanging in one part of the sky for months? What does tomorrow feel like when the light outside barely changes from one day to the next? You can already see small hints of this in places on present-day Earth that experience very long summer days or very long winter nights, especially near the Arctic and Antarctic circles. People there know that extended light can blur the sense of evening, and long darkness can alter mood, sleep, and energy. A stopped Earth would take that familiar oddness and expand it to a planetary scale. The psychological texture of life would change with the sky. There is also a quiet thermal truth worth holding close. On the Earth, day and night share the work of heating and cooling. Sunlight warms the surface. Night allows it to release some of that heat. Oceans and atmosphere store and transport energy, smoothing the extremes, but the rhythm remains. Remove the daily alternation, and the smoothing fails in a new way. The day side keeps collecting heat for far too long. The night side keeps losing it for far too long. The result is a world divided more sharply by temperature than the modern planet, even before new winds and climate systems fully establish themselves. That means the sun would become less like a clock and more like a ruler, dividing the world into long provinces of energy. One side gathers warmth almost obsessively. One side gives it away. The old balance of noon and midnight would vanish. You might wonder whether there would still be seasons in the usual sense. In some form, yes, but they would be transformed. Since Earth still orbits the sun with its axis tilted, the angle and duration of sunlight in a given place would still vary over the year. Yet without daily rotation, the seasonal story would be tangled with this giant day-night cycle. Instead of familiar spring mornings and autumn evenings, you might have months when the sun slowly climbs higher, followed by months when it slowly sinks and disappears. Seasons would feel stretched, magnified, and strangely theatrical, as if the sky had decided to perform in slow motion for an audience too tired to clap. And the stars would become different companions too. On the dark side, the night sky could remain visible for vast spans, uninterrupted by dawn. You would see stars wheel only through the much slower changes caused by Earth's orbit, not by rapid planetary rotation. Constellations would linger. Planets would drift patiently. The Milky Way might become less of a midnight guest and more of a season-long ceiling. It would be beautiful, deeply so, though beauty on a frozen night side comes with certain practical complaints. The brightest irony in all this is that Earth would still be moving furiously through space. It would still orbit the sun at about 30 kilometers per second. It would still travel with the solar system around the galaxy. It would still be part of the great motion of the cosmos. Yet to someone standing on the surface, the loss of daily spin would make the world feel eerily still. The sky would change too slowly. The sun would seem fixed for ages. Time would pool instead of flowing. That stillness would be deceptive, but also hauntingly beautiful. And once the rhythm of light changes, everything beneath it must learn a new rhythm too. Weather would no longer follow the quick pulse of ordinary days. It would rebuild itself around deep heating, deep cooling, and a boundary between light and dark that might become the most important line on the planet. Which is where the climate begins to grow very strange and very quiet in entirely new ways. Once the old rhythm of day and night is gone, the weather has to invent a new personality. That is a strange sentence, but it fits. Weather is not random noise drifting over the surface of a passive world. It is the atmosphere trying over and over to move heat, moisture, and momentum from one place to another. It is a response, a negotiation, a daily improvisation built on sunlight, rotation, oceans, mountains, pressure, and the quiet differences between places. So when you remove one of the planet's most important organizing motions, the weather cannot simply continue with a slightly annoyed expression. It has to become something else. On the Earth, sunlight arrives and leaves on a 24-hour schedule, and the atmosphere has learned to dance with that pace. Land warms faster than water. Night cools the surface again. Air rises where heating is strong, sinks where it is weak, and all of this is gently bent and redirected by the planet's rotation. Trade winds, jet streams, monsoons, cyclones, and the broad climate belts that shape deserts and forests are all tied, in one way or another, to that spinning world. Even when the details become complicated, the background rhythm remains surprisingly elegant. A stopped Earth would erase that elegant daily pulse. Instead of quick alternations between light and dark, the atmosphere would face months of heating on one side and months of cooling on the other. The day side would keep absorbing solar energy long after the ground had become hot. The night side would keep losing heat long after the surface had gone cold. That creates an enormous temperature gradient across the planet, a great contrast between warm regions and cold ones, and air always responds to such contrasts. Warm air tends to rise. Cold air tends to sink. Pressure differences build. Wind forms. The atmosphere starts trying to carry energy from where there is too much to where there is too little. So the climate of a motionless Earth would likely organize itself around a powerful circulation between the hot side and the cold side. You can picture it gently first. On the bright side, especially near the region under the highest sun, the surface heats for a very long time. Air there becomes warm and buoyant, and it rises. High in the atmosphere, that air begins moving away toward darker regions. On the night side, where the surface is cold and the air is denser, the opposite happens. Air sinks and then flows back toward the warm side near the ground, completing a huge planetary loop. It is almost like a giant breathing pattern. Rise in the light, flow aloft, sink in the dark, return below. That is the simplest version, and real atmospheres are always a little less tidy than the first sketch, which is rude but expected. Oceans, topography, seasonal changes tied to the planet's tilt, and the inertia left over from any earlier transitions would all complicate the picture. Still, the broad idea holds. The new weather would be built less around east-west spinning patterns and more around the deep contrast between a heated hemisphere and a cooled one. This matters because Earth's current climate zones would largely lose their familiar logic. The equatorial rain belt, the subtropical dry zones, the mid-latitude storm tracks, the polar circulation cells, all of these depend heavily on rotation and the daily distribution of sunlight. Without the spin, the Coriolis effect would vanish, and with it much of the graceful deflection that turns straight flows into curved winds and helps organize large-scale weather systems. Air would no longer be gently bent into the patterns you have lived under your whole life. A world without Coriolis would feel meteorologically stripped down, simpler in one sense, stranger in another. On the day side, strong heating would drive intense upward motion. That means cloud formation could become vigorous in some places, especially where surface water remains available. Warm air rising cools as it expands, and when it cools enough, water vapor condenses into clouds. So despite the long heat, some regions could develop immense cloud decks, perhaps even persistent storms, depending on how much moisture is present and how the new circulation organizes itself. The bright side of the stopped Earth might not just be dry and blazing everywhere. Some places could become towers of rising humid air, enormous cloud systems slowly evolving under a sun that barely changes its position. Meanwhile, the dark side would likely be drier in many areas because cold air holds less water vapor. Moisture transported there from the warm side could freeze out as snow or ice. Over time, the night hemisphere might accumulate vast frozen deposits, especially if water continues migrating and settling under the new climate regime. The air there would be stable in some places, heavy and dense near the surface, with cold high-pressure regions expanding across the frozen dark. Silence would gather there differently, a cold silence, a patient one. Between the two extremes lies one of the most fascinating possibilities of all, the twilight zone. This would be the broad shifting boundary where the sun remains low on the horizon, or where light gradually yields to darkness. In many models of tidally locked exoplanets, which always show one face to their star, this boundary zone is often considered the most potentially habitable region because it avoids the brutal heat of the day side and the deep freeze of the night side. A stopped Earth is not exactly the same as a tidally locked world, since Earth would still experience annual changes through its orbit, but there is a useful similarity here. The regions near the long dawn or long dusk could become refuges of moderate temperature, depending on oceans, winds, and topography. That gives the world a curious emotional center. The gentlest life might gather where certainty is weakest, where light is neither full nor absent. The edge becomes home. It is easy to imagine these twilight regions as always calm, but that would probably be too generous. They might also be zones of constant atmospheric tension, where warm air from the day side meets cold air from the night side, where fronts linger and migrate slowly, where clouds thicken and winds remain restless. The line between hot and cold would not be a neat pencil mark. It would breathe, wobble, seasonally shift, and gather storms. Storms themselves would change character on a non-rotating Earth. On the present planet, rotation helps storms spin. It shapes cyclones, hurricanes, and the broad swirl of pressure systems. Without Coriolis, large rotating storms as you know them would be fundamentally altered. That does not mean the weather would become gentle. Far from it. Strong heating and cooling contrasts can drive fierce convection, severe straight-line winds, and massive pressure-driven flows. The atmosphere would still have every opportunity to be dramatic. It would simply be dramatic in new geometries. Imagine colossal thunderheads rising from long-heated regions, growing day after day where the surface pumps warmth and moisture upward. Imagine persistent cloud bands stretched along the twilight boundary. Imagine winds that are less about elegant spirals and more about vast, direct movement from one thermal world to another. A stopped Earth would trade some familiar forms of chaos for unfamiliar ones. And the oceans, if they remain in large polar basins or other redistributed shapes as we talked about earlier, would complicate everything further. Water stores heat more slowly and releases it more slowly than land. That means ocean-covered areas would moderate temperature extremes relative to continents. A bright-side ocean might absorb sunlight for months and hold that energy, while a dark-side ocean could resist freezing at depth even as its surface forms ice. Coastal climates, interior climates, and highland climates would all diverge in ways that no present-day weather map is prepared to explain politely. There is also the question of habitability, which we keep approaching carefully because the answer depends very much on where you are. Large parts of the day side could become dangerously hot. Large parts of the night side could become bitterly cold. The most stable regions for life might cluster near persistent dawn and dusk zones, where temperatures are less extreme and liquid water might be available more reliably. Those places could become the new climatic middle ground, the compromise Earth offers after ruining the old arrangement. You can hear a pattern forming by now. The stopped world keeps replacing familiar centers with edges. The old middle becomes too much. The new safety lives in transition. That is true of weather too. The atmosphere would spend its life moving between excess heat and excess cold, between brightness that lingers too long and darkness that will not leave. Climate becomes less about ordinary seasons and more about surviving gradients. Yet there is something almost serene in the logic of it. The atmosphere is still trying to do what it has always done: share energy, smooth differences, carry water, build patterns from imbalance. It may do so in ways that feel alien, but the purpose remains beautifully consistent. Weather is the planet's way of redistributing what sunlight gives unevenly. And once those new patterns settle in, they begin pressing themselves into living things, into leaves and roots, into migration and sleep, into the chemistry of cells and the clocks hidden inside blood and brain. The world's new sky would not just change the weather outside your window. It would move all the way into life itself. By the time you reach living things, the stopped Earth feels even stranger because biology is built on repetition. Life trusts rhythm in a way that is almost touching. Leaves open and close, hormones rise and fall, birds migrate by season and light, coral spawns by lunar timing. Human bodies drift through cycles of alertness, hunger, sleep, and repair, all guided by clocks so ancient and so deeply built in that you rarely notice them unless something knocks them out of tune. A single bad night can make the next day feel oddly fragile. A week of poor sleep can make time itself feel blunt around the edges. So when the sky stops offering morning and night in the familiar way, life does not simply shrug and become philosophical about it. It has to renegotiate everything. Plants would be among the first to reveal how much the world depends on a rotating Earth. Most plants do not just need sunlight. They need patterns of sunlight and darkness. Photosynthesis runs in the light, of course, taking in carbon dioxide, using solar energy, and building sugars that keep the whole green economy of the planet going. But darkness matters too. Plants regulate water loss, growth, flowering, and metabolism through circadian rhythms, internal clocks tuned to day length. In many species, the length of night is a powerful signal. It tells them when to flower, when to store energy, when to rest, when to prepare for cold, when to wait. On a world where daylight can last for months, that timing system begins to lose its old meaning. Some plants might survive long periods of light if temperature and water remain within tolerable ranges. After all, in the modern Arctic summer, some vegetation grows rapidly under extended daylight. But months of continuous sun combined with extreme heat on the day side would be another matter. Many plants would struggle with overheating, drought stress, disrupted flowering cycles, and the exhaustion of physiological systems designed for alternating phases of activity and recovery. The sun, charming as it can be, would become an overbearing guest. On the dark side, the problem turns the other way. No light means no photosynthesis for extended periods. Existing stores of energy can only last so long. Many ecosystems would collapse simply because the primary producers, the plants and algae that form the base of food webs, could no longer keep up. Forests would not merely look different. In many places, they would disappear. Grasslands, croplands, wetlands, and coastal ecosystems would all be forced into new rules by the sky. The twilight regions again start to feel important because they might offer the best compromise. Long low-angle light, cooler temperatures, and the possibility of more stable moisture could allow some forms of plant life to persist more easily there. The edge between the blazing bright and the frozen dark could become a belt of stubborn biology, a place where life learns to live in permanent almost morning or almost evening. It sounds romantic, and for once the romance may not be entirely misleading. Animals would face their own deeply personal confusion. Many species use the light-dark cycle to regulate sleep, feeding, navigation, mating, and migration. Birds time journeys with seasonal change and day length. Insects emerge on schedules shaped by temperature and light. Nocturnal animals rely on darkness as a predictable space for feeding and safety. Diurnal animals rely on day. Marine creatures use light levels to coordinate vertical migrations through the water column, rising and sinking in patterns so widespread that they help shape ocean ecosystems every single day. Remove the daily cycle, and you do not just inconvenience these animals. You remove one of the main clocks by which behavior is organized. Human beings would feel this too, very directly. Your body keeps time through circadian rhythms, roughly 24-hour cycles governed by a master clock in the brain and reinforced by light entering the eyes. Morning light helps anchor wakefulness. Darkness supports melatonin release and the onset of sleep. Temperature, meals, and social routines matter too, but light is one of the strongest signals. In places on Earth today where people experience polar day or polar night, sleep can already become more difficult without careful routines. A stopped Earth would magnify that challenge enormously. Imagine living through a sunrise that lasts weeks. Imagine trying to keep a stable schedule when the outside world offers no daily cue that one part of the cycle has ended and another has begun. People could still invent artificial time, of course. Curtains, lamps, clocks, work periods, designated sleep hours. Humans are good at building small islands of order when nature becomes inconvenient, but the strain would be real. Mood, cognition, hormonal balance, and overall health would all be tested by a sky that no longer helps you keep time. There is a gentle irony here. Human civilization often behaves as if it has outgrown the natural rhythms of the planet. Electric light lets cities glow through the night. Global networks run without pause. Some people eat lunch under fluorescent panels and barely know what the weather did that day. And yet the body remains wonderfully old-fashioned. It still listens for dawn. It still reads brightness and darkness as instructions. Beneath the screens and schedules, you are still an animal living on a turning world. Or rather, you were. Food systems would become one of the hardest practical problems. Agriculture depends on seasonal timing, temperature ranges, water availability, and the regularity of light. On the day side, excessive heat and prolonged radiation could damage crops and dry soils. On the night side, cold and darkness would prevent conventional farming almost entirely in many places. Controlled environments, greenhouses, artificial lighting, and carefully managed twilight zone agriculture might become necessary for survival. The map of where food can be grown would be redrawn as dramatically as the map of coastlines. And then there is the ocean life. Marine ecosystems are tightly bound to circulation, temperature, ice cover, oxygen distribution, and light penetration. If oceans migrate poleward and climates reorganize, the modern structure of marine food webs would shift as well. Phytoplankton, the tiny drifting organisms that perform a huge fraction of Earth's photosynthesis, depend on light and nutrient cycles. Change the light cycle and stratification of the oceans, and you change the foundation of marine productivity. Fish migrations, breeding grounds, coral reef survival, and oxygen levels in various water layers could all be altered in complicated ways. Some species would vanish, some would retreat, some would adapt in ways that are hard to predict. Life is fragile, yes, but it is also inventive. That is one of the reasons Earth's history is so beautiful to study. Again and again, living things survive conditions that seem impossible until they are not. They shrink niches, change timing, move, cooperate, specialize, improvise. Still, adaptation takes time, and a sudden stop gives very little of it. You begin to feel the difference between physical possibility and biological comfort. A planet can remain a planet under many conditions. Life, especially complex life, is fussier. It likes moderation. It likes repeatability. It likes water in the right form, temperatures in a certain range, energy arriving with enough reliability that cells and systems can make plans. Biology is, in its own way, a lover of routine. That is why the ordinary day is such a profound gift. It is not just a convenience for making calendars or catching trains. It is a steady pulse that allows bodies and ecosystems to organize themselves without constant negotiation. Morning means something. evening means something. Seeds, wings, leaves, and nerves all build around that expectation. On a stopped Earth, expectation itself becomes regional. Somewhere under the long, bright sky, creatures would have to hide from heat or move with the shifting boundary of tolerable light. Somewhere under months of darkness, life would depend on stored energy, artificial illumination, geothermal heat, oceanic buffering, or simple endurance. And somewhere near the great belts of dawn and dusk, new ecologies might emerge, tuned to a world where the sun never quite commits to leaving or arriving. It is a quiet kind of wonder, really. Life would not only ask whether it can survive, it would ask what time means now, when to bloom, when to sleep, when to sing, when to wait. And those questions would reach beyond forests and coastlines into cities as well, because human beings do not live by biology alone. They live by systems, machines, navigation, power, habit, and the enormous technological scaffolding that modern life has stretched around itself so confidently. A stopped Earth would test all of that too. Human beings are very good at pretending the planet is simply a platform for infrastructure. You lay roads over it, build ports beside it, stretch wires across it, launch signals through it, and after a while the machinery begins to feel like the main story. Airports hum, servers blink, ships cross oceans with practiced confidence. Satellites help your phone decide where you are with a kind of casual wizardry that would have made ancient astronomers sit down quietly for a while. Modern life can seem self-contained, as if it has floated a little free from the old dependence on sunrise, weather, and geography. But a stopped Earth would be extremely unimpressed by that illusion. The first reason is simple. Nearly every system you rely on assumes a world that rotates in a familiar way. Time zones, navigation models, satellite tracking, launch calculations, weather forecasting, agricultural planning, aviation routes, shipping, power demand cycles, sleep schedules, heating and cooling patterns. All of it is built around a spinning planet with a 24-hour day. Remove that background motion, and the technology does not instantly vanish, but it loses one of the deepest assumptions under its feet. You can start with the quietest example, the clock. Your daily schedule is not just social habit, it is a shared agreement with the sky. Morning, afternoon, evening, midnight, those words grew out of a rotating Earth. Even in the most artificial city, where office lights shine past sunset and delivery vans keep moving long after midnight, the underlying pattern still comes from the planet turning beneath the sun. On a stopped Earth, clocks would remain, of course. Humans would keep hours because humans are stubborn and enjoy labeling things. But the meaning of those hours would become more artificial than ever. A workday could still be 8 hours. Sleep could still be scheduled. Meals could still happen on a timetable. Yet none of it would be reinforced by a normal dawn outside the window. Civilization would have to become its own sunrise. Electric lighting would stop being a convenience and become a biological necessity in many places. On the night side, long darkness would require sustained illumination for homes, workplaces, farms, and public spaces. On the day side, shielding from constant brightness and heat would become just as important. Curtains, reflective materials, underground spaces, thermal insulation, and controlled indoor climates would matter far more than they do now. Whole cities might migrate toward the twilight zones, simply because those regions offer the closest thing to a workable compromise between energy, temperature, and human sanity. Energy systems themselves would be pushed into new shapes. Solar power on the bright side might seem ideal at first, because the sun lingers for ages, but extreme heat, dust, storms, and regional instability could complicate that picture. On the dark side, solar becomes useless for long stretches, which means stored energy, nuclear power, geothermal sources, imported fuels, or massive transmission networks would become crucial. A stopped world would split energy strategy by geography in a much harsher way than the modern world does. The electric grid, which already dislikes being surprised, would have every right to become dramatic about this. Transportation would be equally transformed. Roads and rail lines can be rebuilt in principle, but their usefulness depends on where people can actually live, farm, and work. If the most habitable regions shift toward long twilight belts, entire transportation networks would need to be redesigned around new population centers. Ports might vanish as coastlines move. Inland cities might become coastal. Coastal cities might become drowned, frozen, or irrelevant. The economic geography of civilization would be redrawn by the new logic of water and temperature. Air travel would face its own difficulties. The atmosphere on a stopped Earth would likely settle into persistent large-scale flows between the hot side and the cold side, with powerful winds and altered storm systems. Aviation depends deeply on understanding the sky. Pilots already use jet streams, avoid turbulence, and navigate around weather shaped by a rotating planet. A non-rotating Earth would create a different atmosphere entirely, and those differences would matter from takeoff to landing. Routes that once felt efficient might become unmanageable. Airports in extreme zones might be abandoned. The map of global air travel would become less a web and more a cautious set of corridors through the least hostile air. Shipping would not escape either. Ocean routes depend on ports, coastlines, currents, winds, and predictable weather windows. But the seas themselves may have migrated, and the climates around them would no longer follow familiar seasonal patterns. Harbors could disappear. Polar waters, once marginal or frozen, might become central basins in the new geography. Equatorial regions that were once defined by shipping lanes across warm oceans might turn into dry land or fragmented interior basins. The ocean would still connect places, but not the same places and not in the same way. And then there is navigation. This is where the stopped Earth begins to feel oddly philosophical, because navigation is really the art of trusting stable patterns. You look at the stars. You read the sun. You use magnetic fields, clocks, radio signals, orbital systems. You assume the sky behaves in consistent ways. You assume the planet beneath you keeps its old habits. On modern Earth, satellite navigation systems such as GPS are built using extraordinarily precise timing and orbital knowledge, all referenced to a rotating Earth. The system already has to account for relativity, atmospheric effects, and the actual shape of the planet, which is impressively petty of the universe but also beautiful. Change the rotation of Earth, and the reference frames themselves change. Navigation would still be possible, but the models would need major revision. Satellites in orbit would face a peculiar transition too. Earth stopping its rotation does not directly stop the satellites, because they are already moving under orbital mechanics, not being carried along by the surface. In that sense, space remains wonderfully indifferent. A spacecraft orbiting Earth continues to orbit Earth, but many aspects of how satellites serve the surface depend on the rotation below. Geostationary satellites, for example, work because they orbit once every sidereal day above the equator, matching Earth's rotation so they appear fixed over one spot. If Earth no longer rotates, there can be no geostationary orbit in the same useful sense. A satellite with that orbital period would no longer hover over a single point on the ground. The whole idea of stationary communication coverage from space would have to be reimagined. That detail has a quiet elegance to it, one missing planetary motion, and a familiar class of orbit loses its personality. Launches into space would change as well. Right now, Earth's rotation gives rockets a helpful eastward boost, especially near the equator. Launching east lets you borrow some of the planet's rotational speed, which saves fuel. Without rotation, that free assist disappears. Every launch becomes a little more expensive in energy terms. It is not the end of spaceflight, but it is one more reminder that civilization has been quietly profiting from planetary motion the entire time. Communication networks, whether satellites, Earth observation, military systems, broadcasting, mapping, all of them would need to be rebuilt around a new sky and a new surface. Even simple assumptions like when power demand rises, when roads are busiest, or when people are likely to be asleep, would break apart when the old light-dark cycle vanishes. The stopped Earth would not destroy technology because technology is fragile. It would disrupt it because technology is specialized. It was designed for a world that moved in very particular ways. Still, humans would adapt where they could. They always do. You can imagine great twilight cities growing under permanently low golden light, roofs engineered for thermal control, agriculture managed in enclosed belts, transport following narrow habitable corridors, clocks kept by agreement rather than sky, children learning in school that day and night used to happen every 24 hours, which would sound to them slightly made up. There is something tender in that image. Civilization becoming more deliberate because nature no longer does the easy timing for it. People choosing light, choosing sleep, choosing where to build because the planet no longer offers many casual places to live. And yet even this great technological adjustment depends on one big mercy, that the stopping happened fast and the world somehow continued at all. So it helps to soften the thought experiment for a moment and imagine a version where Earth does not halt in an instant, but slows over ages, gradually, almost politely. Because that gentler version tells you something important too. The instant version of this story is dramatic because it breaks everything at once. It pulls the rug out from under the oceans, lets the atmosphere keep running after the ground has quit, and turns a familiar planet into a catastrophe before anyone has time to finish a sentence. That is useful if you want to understand momentum in the most vivid possible way, but it is not the only way to imagine a stopped Earth. There is another version, slower and quieter, where the spin fades over millions of years or even longer, and that version feels less like an accident and more like a transformation. It is gentler to think about for a while. In that slower version, the planet does not suddenly betray everything living on it. Instead, the length of the day gradually stretches. 24 hours becomes 25, then 30, then 40, then longer still, over spans so vast that no single human life could ever notice the difference directly. Generations would inherit a world with slightly altered timing, and their descendants would inherit another. Biology, climate, coastlines, and culture would have time to respond in steps rather than in shock. This kind of slowing is not pure fantasy, by the way. Earth's rotation is already changing, just at a very slow pace. The moon raises tides on Earth, and the friction associated with those tides gradually transfers angular momentum. As a result, Earth's day lengthens by a tiny amount over time, while the moon slowly drifts farther away. Hundreds of millions of years ago, days were shorter. In the distant past, Earth rotated more quickly than it does now. So the idea that spin can change is real. The only unrealistic part in this gentler scenario is the scale and destination, taking the process all the way to a stop. And that changes the emotional tone completely. A slowly slowing Earth would give life a chance to negotiate. Plants would experience longer periods of light and darkness, but over evolutionary timescales they could adapt. Circadian rhythms might shift. Some lineages would fail, certainly, because life is selective in that cold little way, but others would adjust, diversify, and find new strategies. Daily cycles would still exist for a long time, just stretched. The world would not wake one morning to discover that dawn had become a season. It would drift there so slowly that entire ecosystems would be reshaped in stages. Weather would evolve too. As Earth spun more slowly, the Coriolis effect would weaken. Winds and storm tracks would gradually reorganize. The familiar climate belts of the modern world might broaden, shift, or dissolve into new arrangements. Dayside heating and nightside cooling would become more pronounced because each side would spend longer in sunlight or darkness before changing again. But the atmosphere and oceans would have time to respond. Heat transport patterns might change slowly enough for climates to migrate rather than collapse. Deserts could expand or relocate. Rain belts could linger longer in some places. Monsoons might grow more intense or more persistent in regions sensitive to prolonged heating. You can imagine long, warm afternoons becoming even longer over geologic time, their heat sinking deeper into the ground, their clouds growing more patient, their nights arriving later and staying longer too. It would be a strange elegance, a world where the daily pulse stretches like music played at half speed, then slower still. The oceans in this gentler version would also behave very differently. Without the sudden shock of momentum, there would be no instant global surge racing across stopped continents. Instead, sea level and ocean distribution would respond gradually as Earth's equatorial bulge diminished. Water would begin shifting poleward over immense timescales, and coastlines would migrate accordingly. Civilizations, if they existed throughout those ages, would experience changing shorelines the way ancient peoples already experienced rivers shifting, deltas growing, or seas advancing after ice ages. Slow enough to record, slow enough to adapt to, but still profound. That is one of the more soothing lessons in planetary science. Time can turn disaster into transformation, not because the physics becomes smaller, but because living systems can respond when given room. Sudden change is cruel. Slow change is still difficult, still full of loss, but it allows for learning. Human culture would probably change in fascinating ways along the path. A day that lengthens gradually would alter work, sleep, calendars, religion, architecture, agriculture, and language. At first, the difference might be almost invisible, only detectable with careful measurement. Later, it could become part of ordinary life. People might divide longer days into artificial segments. Cities might use shading and lighting more deliberately. Social time would drift farther from astronomical time, because once the natural cycle becomes awkward enough, human beings usually decide to edit reality with schedules and walls and lamps. Which is a very human response, honestly. The cosmos changes. You build curtains. At some point, though, the stretching day would begin to reshape the climate more dramatically. Longer exposure to sunlight would allow land to heat more deeply, and longer nights would allow stronger cooling. Seasonal contrasts might interact with the longer rotation in complicated ways. Ocean currents, already sensitive to wind and temperature differences, could reorganize. Ice sheets might grow differently. The habitable regions of the world could migrate, but not abruptly. The biosphere would shift with them, as it has many times before in Earth's history. This slower version also helps you see something else. The planet's present balance is not sacred. It is just the version that exists now. If Earth turned more slowly, a new normal would eventually form. Children born into that world would find it ordinary. They would think a long dawn is simply what dawn is. They would structure thought and language around the rhythms they inherit, not around yours. The sun's slow climb would feel ancient and proper to them. Your quick 24-hour cycle would sound rushed, almost impolite. That idea has a certain softness to it. So much of what you call normal is only familiar timing. And if the spin slowed enough, all the great consequences we have been carrying through the night would begin appearing in gentler form. The atmosphere would reorganize, the oceans would creep, the equatorial bulge would relax, the day-night cycle would stretch toward the scale of seasons, twilight zones might become increasingly valuable, life would retreat from some places and flourish in others, technology and culture would adapt, the map would change, the sky would teach different habits. It would still be a different Earth, just not a world broken in a single rude motion. There is also a kind of cosmic humility hidden in this gentler scenario. Many worlds beyond our solar system likely live under conditions that would seem bizarre by human standards. Some rotate quickly, some slowly. Some may be tidally locked to their stars, one face always bright, one always dark. Some have thick atmospheres, strange chemistries, unfamiliar seasons, and skies no one has yet seen directly. Compared with those worlds, Earth's present rhythm is only one possible arrangement among many. Beautiful, yes. Life-friendly, yes. But not inevitable. So a slowly stopping Earth becomes more than a disaster scenario. It becomes a way of appreciating how delicately motion shapes habitability. Rotation helps decide wind. Wind helps decide ocean currents. Currents help decide climate. Climate helps decide ecosystems. Ecosystems help decide where civilizations rise, what they grow, how they build when they sleep, what stories they tell about the sky. One planetary motion, quiet and constant, threads itself into almost everything. And when that motion changes slowly enough, you can finally see the thread. By now, the stopped Earth no longer feels like a simple question with a dramatic answer. It feels like a meditation on hidden structure, on all the movements that stay invisible only because they are steady, on all the balances that feel permanent only because they change more slowly than a human life. The world has been turning this entire time, carrying you with such elegance that you almost mistook it for stillness. That quiet mistake might be the loveliest part of all. And it leaves you with one last thought, wider than weather or oceans or cities, something almost tender about the way motion holds the world together, and how easy it is to forget the dance while you are being carried by it. By the end of this long thought experiment, the strangest part is no longer the violence of the stop. It is the realization that Earth was never giving you stillness in the first place. It was giving you steady motion, layered so smoothly and faithfully into everyday life that it passed for rest. The ground beneath you felt quiet because it moved with perfect consistency. The sky felt familiar because the pattern repeated. Morning returned often enough to feel guaranteed. Night arrived often enough to feel kind. The planet carried you through one of the most elegant motions in the solar system, and somehow made it feel like home. That may be the real wonder hidden inside the question. You begin this journey imagining a sudden stop because it sounds dramatic, because it lets physics reveal itself all at once, because it pulls the hidden machinery of the world into view. And it does. It shows you inertia in the air, momentum in the seas, the delicate geometry of a slightly bulging planet, the strange dependence of weather on spin, the way life builds itself around rhythm, the way cities and satellites quietly borrow from a turning Earth every single day. It shows you that motion is not just something planets do. Motion is part of what makes a planet livable. A rotating Earth shares out sunlight, it smooths heat, it helps organize winds, it shapes the oceans, it offers biology a reliable pulse. It gives civilization a rhythm so ordinary that people sometimes resent the alarm clock without ever thanking the planet. Fair enough, perhaps. Gratitude before coffee is difficult. Still, the point stands. The day is not a decorative feature. It is infrastructure. And once you see that, the ordinary world becomes more beautiful. The next time sunlight moves slowly across a wall, you can remember that the wall is not passively waiting for brightness. It is being turned into it. The next time evening arrives and the air cools and the shadows lengthen across a road or a rooftop or the edge of a field, you can remember that darkness is not pouring in from above. You are being carried into a new angle. The next time you see stars rise over a quiet neighborhood, it is worth remembering that the sky is not hurrying around you. You are rotating into the view like someone entering a grand theater, without hearing the stage machinery at work. There is something deeply calming in that. The world is in motion, but the motion is not frantic. It is measured, ancient, reliable. Earth turns once in about 24 hours and has been doing some version of that for billions of years, adjusting slowly through time, never perfectly frozen, never fully still, just steady enough for oceans to learn coastlines, for forests to learn seasons, for bodies to learn sleep, for memory to learn what a day feels like. And perhaps that is why the stopped Earth feels so haunting. It removes not just motion but trust. It takes away a pattern so deeply built into the structure of life that even your language leans on it. Soon, later, tomorrow morning, last night, sleep in, stay up, early light, late afternoon. These are not just phrases. They are little cultural shells built around the turning of the world. A stopped Earth would ask life to invent a different poetry. It might, over long enough time, succeed. Twilight civilizations might rise. New ecologies might claim the long dusk. People might build their homes where the light is gentle and teach their children that the old world once had daily sunrise and daily nightfall, which would sound almost too neat to be true. They would adapt because life adapts, and because human beings, for all their occasional foolishness, are remarkably good at making routine out of difficulty. But even in that future, the memory of the spinning Earth would deserve reverence. It would deserve the kind of quiet respect you give to something that worked so well you forgot it was working at all. The cosmos is full of motion like this. Moons circle planets, planets circle stars, stars orbit galactic centers, galaxies drift through clusters. Nothing is really standing still. Stability, when it appears, is usually the result of balanced movement rather than the absence of it. You feel secure not because the universe has paused for your sake, but because its motions often settle into rhythms generous enough to allow life. That feels like a lovely thing to know at the end of the night. You are living on a planet that spins, tilts, wobbles slightly, circles the sun, carries a moon that slows it little by little, rides with the solar system through the Milky Way, and still manages to offer you ordinary mornings with enough gentleness that you can stand in a kitchen half awake and think the whole world is quiet. Which is absurd, honestly. Beautiful, but absurd. And maybe that is the final soft lesson here. Reality does not need to be still to be peaceful. The deepest forms of peace may come from motion so balanced that it feels like rest. A turning planet, a breathing atmosphere, tides answering the moon, seasons arriving on time, the body keeping its own clocks inside all of that, making sleep from darkness and wakefulness from light, trusting the world to continue its patient revolutions. So if Earth suddenly stopped spinning, the consequences would be immense. The atmosphere would race on. The oceans would move with terrible memory. The shape of the planet would no longer fit its condition. Day and night would stretch into long seasons of light and dark. Climate would reorganize around extremes. Life would struggle to adapt. Technology would have to relearn geography, time, and habit from the ground up. The world would survive in some form, but it would no longer be the Earth that taught you what a day is. And because of that, the Earth you have right now feels more precious. A world where dawn arrives on schedule. A world where evening cools the ground. A world where sleep can come in ordinary darkness. A world where the sky changes often enough to feel alive, but gently enough to feel safe. That is a remarkable arrangement, quietly miraculous, even if science would prefer less dramatic wording, which it often does. Science likes understatement. The planet spins at enormous speed, moves through space at even greater speed, and somehow produces a bedside glass of water that looks still. If that is not elegance, it is difficult to know what is. So you let the thought experiment settle. You let the stopped world drift away. You return softly to the moving one, to this one, to the turning earth beneath your room, beneath your street, beneath the sleeping trees and the distant sea, carrying every roof and window and memory eastward through the dark with such patience that you barely notice. And tonight, maybe noticing is enough. The world is moving. Quietly, faithfully, beautifully. Let that be comforting. You do not need the planet to stop in order to understand how gently it has been carrying you all along. The fan hums. The room grows softer. The night outside keeps its own calm shape. And far below every building, every road, every resting animal, every wave folding onto some unseen shore, Earth continues its ancient turning, almost politely, as if it has no interest in rushing, as if it knows that the best motions are the ones that hold you so steadily you can finally close your eyes inside them. For a little while, just keep that feeling nearby. You are on a moving world, and it is doing a beautiful job. Now the thought can loosen. The questions can loosen too. The giant winds, the wandering oceans, the long day, the frozen dark, the strange new coastlines, all of it can fade back into the quiet place where imagination stores the big impossible things. What remains is simpler. A round world turning in darkness, a star at the right distance, air wrapped close, water shifting under moonlight, a body growing tired at the end of the day because the day came and went exactly as it was supposed to. That ordinary rhythm is more precious than it looks. So let your mind drift back to the earth you know, the real one, the one that keeps moving without asking for applause, the one that trades sunlight for starlight with perfect patience, the one that makes morning and evening out of motion alone. You do not have to hold the whole planet in your thoughts anymore. You only have to rest inside it. Let the spinning become a softness. Let the darkness become gentle. Let the vastness stay far away now. There is nothing you need to fix tonight. Nothing you need to calculate. Nothing you need to carry. The oceans can keep their distance. The winds can stay in imagination. The stars can remain where they are, slow and clear and quiet above a world that still knows how to turn. And you can simply be here, warm and safe, on this faithful moving earth, while the night settles around you in the old familiar way. The room is still enough. The hour is soft enough. Your thoughts can grow lighter now. Just breathe slowly. Let the day dissolve. Let the planet hold the rhythm for you.